not just myself, but everybody sort of involved. It's a little bit awkward at times to try to find somebody for an adult job. And you guys being guinea pigs helps out a lot. The other thing that I always find it a little bit interesting, you don't see it from the other perspective. It takes a lot of sort of trust for people to believe in your opinions. And when they sat down afterwards, remember how you filled out that form that gave the numbers for the person? We had three candidates came in, so 3 different classes gave those numbers. They put a ton of weight, though, into what you guys actually have to say. The district, over the course of our adult lives working here, everybody makes over, what do you have to, I think over 30 years, probably an average person earns more than $1 million. So you had a voice in a $1 million decision that gets made by the district. That's kind of a big deal. It was very interesting, too, to see the comments that people gave back. You guys are very insightful. It's very obvious for some of you. You actually know what it means to do this part well. There were comments on it that were like, hey, this person did this well, and they did this well, and I know some classes we don't do this. So thank you very much. I think we left off last time. It looked like there were 2 left. Is that right? 2 things. All right. So let's get those last 2 done. I'm sorry. I thought we finished all of them. Oh, we did, though. The other day, we did go in and, yes. I'll get you. You can fill it in, I think, when you get. Where's your locker? Is it on the other side? No. Oh, then just head down and grab one of those passes. No. We need this. So, where did we get? All right. So we were down here. Oh, and we were here when the board wasn't working also, or was it working for you guys? As we were going through, we had 2 factor patterns left to go through and do. One of them is sum and difference of perfect cubes. Now, we've learned difference of squares. You should be good with that one. The one that you have not done yet is difference of perfect cubes. And when you're going through and doing perfect cubes, you first need to make sure you know what your perfect cube numbers are. Just like our perfect squares are numbers like 1, we don't count 1, 4, 9, 16, 25, 36, and so on. You've got to be able to generate, sort of off the top of your head, maybe on the fly a little bit, a list of perfect cubes, too. We're going to list it out underneath that pattern there. Who can tell me any number that's a perfect cube? Hands up, please, if you can tell me any number that you know or can think of that you would get by multiplying a base times itself 3 times. So what's an example of a perfect cube? 27 is 1. That's our 3rd one on the list. Who can give me one that might be before it? 8, and there's 1 even before that, but what's that one? Nope. 1. 1 cubed is going to give you 1. So as we do this out, your list should go. It's a 1, it's an 8, it's a 27. After 27, 4 cubed is 64. That's 1, 2, 3, 4, 5 would be 125. 6 would be what? 216. 7 is 343, and so on. That's the first thing we need to make sure you know. You've got to know what those are. The second thing is, when you see that pattern, you can do a sum of perfect cubes. You can't do a sum of squares, but you can do a sum of cubes. And when we do out the sum of cubes, it factors down into a binomial and a trinomial. Binomials have 2 parts. Trinomials have 3. What separates these answers from each other? Take a look. When it's a plus going across, your signs are plus, minus, plus. So make sure somewhere on there I'd probably indicate that. And then when there's a minus, the signs going across are minus, plus, plus. This one, more than any of the ones you've done so far, is really kind of like building a house. The first thing you do is make space for stuff, and then you fill it in. So if I were to do out example A here, hopefully we can recognize that both of those are perfect cubes. Who can tell me what's the cube root of, and we'll do the top one up here, 27m cubed plus 8. What's the cube root of 27m cubed? Hands up, please, if you can answer that. What times itself 3 times can get me to 27m cubed? Let's wait for 8 of us that can get us there. We got 1, 2, 3, 4, 5. What do you want to say? 3m. Yep. So, in all honesty, I write that out real small above it. That's sort of the A term. In the pattern, that's the A. Now, the cube root of the right. Let's fill that in. Hands up when you can tell me what's the cube root of the term on the right. 2. So I put a 2 there. Now when I go over here, you're going to list out a binomial in parentheses and a trinomial. So give out space to fit 2 terms and then 3. So go through and list that part out. And our signs going across, we can also fill in. Since this is plus, they go plus, minus, plus. And that's from the factor pattern that's on the left. When we do this out, the binomial is the A, then the B, or the left and then the right, but not the original ones, the cube root ones that you listed out up above. With that in mind, who thinks they can give me the binomial factor? What do you think would go in this binomial factor? Take a look at what's there. See how the pattern looks? If this is the rule, I think this might be what the first one would look like. We got 1, 2, 3 of us who can take that. Hopefully it's not too much. We want to say 3m plus 2. Perfect. The left and then the right. So this would be a 3m plus 2. Now, this is the next part is where we're going to get some errors. Look at the right trinomial that's going to be there. Remember your signs are going to be, what was it? Is it a sum? Yeah, so plus, minus, plus. So this is our minus plus area. And by the way, when we start filling this in, notice this says a squared. Take a look. Who's got a guess, maybe a strong one, what you think you'd get if you took the A and squared it based off of what you've listed out so far? Take a look sort of what's there. What do we think might be the A squared value or lead that trinomial? Okay, sort of not to know, but at least I hope we're okay with getting to a guess. There's a common answer for it that might just be a little bit off. By the way, you should already see how to find what sort of A is. When it says A squared, you kind of look back. What would you got? Why would you say 9m squared? What did you do? Yeah, take the cube root that you had and then square it. So now this is going to be 9m squared to start. And by the way, the next sign is a minus. Now it tells you next to take A times B. So go back above. Let's see if we can get 6 of us who can tell us what you think you'd get if you took A times B now. Extend the pattern. We got 1, 2, 3 of us. 4. And plus, what are we going to have at the end? Look at what's there. Hands up if you can tell me what you think you'd have. We got 1. We can get 6. 1, 2, 3, 4. 4. There you go. That's why it's so critical, bless you, to list those values out. You want to see what they are because that's the A and the B in the question. The pattern is left. When I say left and right, these are the numbers I'm talking about, the expressions. Left, right, left squared, left, right, right squared. It's the same thing. A, B, A squared, A, B, B squared. Do we have questions on that?
I'm just kind of confused about the plus, minus, plus thing.
The sign pattern, you mean? Yeah. That's just a memorized thing, and it comes from whatever's happening between the 2 terms, between your cubes. So if it's a sum, it goes plus, minus, plus. If it's a subtraction or a difference of perfect cubes, it goes minus, plus, plus then. That's the only difference, by the way, between the 2.
So the 9m squared comes from the 3m squared?
It's 3, and this is where we make our mistake, is they're coming up. I'm not going to pretend to know what they show you over at Sprott. These things are different. This and this are not the same. What's the pitfall that a lot of us are going to have? You will always square the variable properly. A lot of times in the beginning, you forget to square the coefficients. That's it. Okay? That's why it's 9m squared and not 3. Did that answer that?
No.
Sorry.
So like, the 9m squared comes from where?
It's this A term, whatever's on the left, squared. The cube root of it squared. So to the 2/3 power
So
cube.
then the 6m, is that like just
That's left and right, A and B. Right? So multiply them together to get the 6m. And the minus is there not because the product here is negative, but because of the sign pattern from before.
and then the 4 is the 2 squared?
There you go. And if it helps in the beginning to label them A and B, do it. You've got to make it work for you. You're going to go through right now. What is the only difference between the first example on the right and the second one? Who can tell me? What's our difference going to be? The plus and minus. So you're going to list out a binomial, trinomial, fill in your sign pattern going across. This one will be different, as we said before. When there's subtraction going across, what will your signs do? Goes minus, plus, plus. Fill them in. Give it an attempt right now. If it doesn't work, we'll erase it. Don't worry. Don't judge. Fill in what we need to, and let's see how far we can get. Let's start off with this. Who can tell me what's the cube root of the left and the right, or what would the A and B be in that second example? Hands up if you can tell us that. What would we start with? We got 1, 2, 3, 4 of us. What do you want to say? So I go over here, put in an N and a 4. That way I sort of keep that in mind when we're doing this out. Now, who can tell me what they think our binomial is going to be? Just the binomial. Outstanding. Binomial is n minus 4. How about our trinomial, please? What do we think we're going to get there if we expand that one out? What do you want to say? Just so you're aware, see how there's a trinomial there? Your inclination right now should be, well, wait a minute. Can't I factor that more? It looks like it would be one of our fast factoring ones. It's n squared plus 4n plus 16. What's the problem with that? You've got n squared plus 4n plus 16. To factor that down, you'd have to see are there numbers that multiply to 16 and add to 4. What numbers multiply to 16? Well, we got 1 and 16. Does that add to give us 4? No. We got 2 and 8. Does that work? No. It would be nice if there was 6, but it's not. And what's left? 4 and 4? Is that going to work? No. So does that trinomial factor down? Another thing that some of you do, at least when you're taking it a little bit beyond like a basic low-level class, you will have a lot of questions that maybe don't factor. That happens in life. Stop thinking everything factors down. It doesn't. No matter how many times we ask you, it still won't happen. Like there's no way to break that down any further. And by the way, who can tell me what I would get if I took and multiplied? I guess this would be a triple distribute. Who can tell me what I would get if I multiplied those two together? Who can tell me what I'd get if I multiply that binomial times that trinomial? This shouldn't take us this long. Hands up, please, and you can tell me, what should I get when I multiply n minus 4 times that trinomial? In the back, what do you want to say? Thank you. These multiply, is it minus? Yeah. These should multiply to give us what the other one is. That's how it should work, okay? So when you're factoring something, you know what it should multiply to. It should give you out the original. And by the way, what's a number that would make this whole thing to be equal to 0 based off of how this looks? This is your expression. What's a number value I could plug in that would make the whole thing equal 0? Hands up when you can answer that. What's a value of n that when I plug it in causes the whole thing to equal 0? Come on. You got 1, 2. Maybe we didn't read the back of our foldable yesterday. I thought I had it on there. You want to give it a try? Yeah. Who can tell me why 4 is an easy way to make that whole product equal 0? Oh, wait a minute. I'm talking about in this form. You're right up here, it would. and you're not wrong. I'm saying if it's listed out in this form, how do you know that 4 would make the whole expression be 0? That's it. 0 times anything is going to be what?
0.
There you go. So if you can make that connection, that's why we factor. You can tell me right away when this will equal 0. We know 4 will, and whatever answers to this will also. But we know 4 will. Okay? So we got one more left to do, right? We didn't do guess and check yet? Or did you? You didn't? Okay. And I'll tell you this. This example isn't on there. What if I gave you something like... okay. This isn't on there. This is a watch and see. I'm doing this different from the one that's in there because I don't know what they did with you before. I don't know how they showed you to factor this down. But just so we're all on the same page, did you all do foiling or multiplying two binomials before last year? Yes or no? Maybe like a box where you start. Did you multiply stuff like this together? 2x minus 5 and 3x plus 2. Did you multiply these together? Did they show it to you by doing first, then outside, inside, and then last? Something like that. Sometimes people list it out with a box. Did they do both? Or? Okay. I'm going to tell you, I'm sorry, I don't want to crush, and if you love the rectangle, go for it. When we do math, and when you're outside of a middle school, that rectangle of dysfunction thing doesn't happen anymore. You can list it on your paper if that works for you. Don't do what works for me, works for you. But when I do examples, I talk about foiling, which is first, outer, inner, last, not the rectangle box, and then put terms together. Now, in this, you're trying to factor this expression down. Our goal, if this does factor down, it will be two binomials. And in this lead position here, I need values. And in that yellow lead position, what do those two yellow values have to multiply to give us? Hands up if you can recall. What needs to go in that yellow spot? And really, we're lucky because there's kind of only one way we can make this happen. Who can tell me what would go in our yellow spot? We got 1, 2, 3 of us. 4, 5, what do you want to say? Perfect, because that gives you a 3m squared. And by the way, why is it good that it's a 3m in front? You would have hated it if this was like a 12, and not because 12's bigger. Why would you hate it if it was a 12 in front? This is the part where you start thinking a little bit more and running through error analysis. Why would it be weird to have a 12 in front? It would kind of really, really suck to have a 12 in front. Like, it would make the question really bad. Yeah. What's another option if there's a 12 in front? Or, there's one more. M and 12M. So there's a lot. And by the way, we could change the order. I mean, it's a lot. Lucky that this is prime. We need values at the end here. And what do these numbers in the green spot have to multiply to? Hands up, please, if you can tell me what the green values are going to multiply to give us in our original. We got 1, 2 of us. What should I get from multiplying those green spots together? -3, this is the number that's at the end. We're kind of lucky there too, ish. What could go in that green spot? Hands up, please, if you can tell me. What's something you want you could put in that green spot? One person can tell me numbers that multiply to -3.
-1 and 3.
Or what else could you use?
-3.
Now, the part for me where we need to make sure you're actually, invested here. This is nothing more. It's called guess and check for a reason. We make a guess, and after you make a guess, what do you think you do? Check to see if it works, and if it doesn't work, what do you think you do? Guess again. Oh, okay. And when you go home, do you think your parents are going to love you any less? Maybe. Anybody have parents who would love them less if they don't factor right the first time? Maybe. Maybe a little bit. Some of you approach it like you're afraid of getting it wrong. we're going to give you questions that are designed to have you like encounter errors. I'm not going to give you more worksheets. Did you guys, maybe this is, well, did you have before like where they give you the worksheets with the riddle at the bottom and things like that? Did you have those? Yeah. Yeah, we don't do that, okay? You just get questions where you're like, oh my God, this is hard. That's the whole point. Like when I was going through, I'm trying to find something for us to even do for our first day of functions. I had to go through and, did it go away? Maybe it's down here. Yeah, so here's some of the stuff that we'll do like within our next unit. And people start freaking out because they go, oh my God, I can't possibly do these questions out, right? Like take a look at this. If that's your function, find f of negative 6. Well, if that's f of x, how would you find f of negative 6? Oh, so is that hard for you? You can imagine why people would be shocked when you ask them with a fraction. Get real. Get real. And by the way, should I expect you to get A and B right all the time? Yeah, there's nothing defective about any of you. You guys are, or should be, computational pros. Meaning if I tell you to plug in a number and give me an output, get it right every time. We'll try some stuff that makes it a little bit harder, like instead of plugging in a number, you can plug in a variable sometimes. I mean, really, like, I don't know. How about how challenging, where was the one? Oh, there's ones up here that dealt with like an area formula. Yeah, area is equal to pi r squared. Find the area. The radius is 3. Can you plug a 3 in and evaluate? Sure. I mean, stop acting. I don't want to dismiss it. Some of the topics that we're going to do is tough, but there's only so many ways to add, subtract, multiply, and divide. Right? Now, what was, oh, let's check to see, by the way. I forgot to go over it. Does this work? Well, let's check. What do you get when you do first terms? 3m squared, the outside give you 9m, inside is negative 1m, last terms are negative 3. Why was that a good guess? Why was that a good guess? How about because it worked? Right? That's probably, I'd call it a great guess because it worked out. Like this gives me the 8 I was looking at. Yours, though, is what? 2m squared? Now, as you're doing this, you should actually be grateful. This could be much harder. Why are you happy that this starts with a 2x squared? Or is it 2m squared or 2x squared? Why are you happy this starts 2m squared as opposed to 4 or 12 or 6? Disaster numbers. Hands up, please, if you can tell me why. One person. 2. 3. Why are we happy to see that 2 in front? Yeah. So what would you fill in based off of what's there? Yeah, and to start it off, we've got an 2m and an m. So fill that in. Now we're going to take a guess. The numbers at the end, what do those numbers in the back here need to multiply to? Hands up when you can answer that. What do the numbers in the second spots need to yield? Go ahead. Perfect. We can get a negative 1 and a positive 3 or a negative 3 and a positive 1. Plug them in and try. See which ones work. Do the FOIL. And if it doesn't work, that's why God invented erasers. We've got more if you need to borrow them. See, we'll wait for 8 of you with your hands up who can tell me what we would get if we did this out all the way. We got 1 so far. 2, thank you. 3 of us, not bad. 4 of us, great. Again, make the replacement. If it works, great. If it doesn't, you just erase and try again. And I'm going to show you, by the way, once we get this done, I'm going to show you ways to eliminate some answers also. We got 1, 2, 3, 4, 5. What do you want to say? Now, let's try and see if that answer is in fact right. First terms are 2m squared. Outside terms are negative 6m. Inside terms are positive 1m. And then minus 3. What do those come together to give us? Did it work out when we did our FOIL? Yes or no? And by the way, one of the things that's interesting, if you don't get this right, you'll know also. Which means if you don't get it right, you're interested in getting the points, you sort of just keep going on. I'm going to tell you this. The last one that we just did had some quirks to it. Now, I think this was it. I'm not 100%. I think this was it, right? So here's what's interesting. We start off and you have to have a 3m and an m here. This is the part where you can make a real intelligent choice. Do you have a question on this? On the last one?
Yeah.
Okay?
So, does it matter if the negative 3 in the other one?
Yes, because that's going to give you something different. Watch how different this would be.
Yeah, that's what I think. Not playing it so
Right, it shouldn't then. If you did this,
how do you know where to put it?
you try. You literally plug it in. Not to minimize it. Some of you are looking for a pattern like solving an equation, meaning when this happens, you do this. There isn't one. It's literally, and I don't want to say a blind guess because I'm going to show you in a minute how to make an educated guess, but it is truly guessing. Which, remember why we said it's going to be a bear? If it's like a 4 in front, or God forbid a 12, you won't know which ones to even start with. So you're going to just run down and be like, all right, it didn't work with a 2 and a 1. I didn't work with a 6 and a 3, whatever it ends up being. Okay? Now, if we did this one out, you'd get 2m squared. The outside would give you plus 2m. Inside would be minus 3. That's not going to get you the negative 5. Here's the piece from the last one. These values at the end we said needed to multiply to give you a 3. I would never even make this guess. Did anybody look at that and see, I don't even know if this works, but I know it can't be the answer. I guess this. I do know it doesn't work. That can't be the answer. And it has to do with what happens when I randomly put the 3 in the other spot. Why would this not equal that? You can see why. You see anything?
Because, like, if you do 3 times n, then you have positive. If you do 3 times n, then you have positive 3
Oh.
n. 3n times negative 1, obviously.
So you're looking at the second part of it. I'm saying I can tell you this isn't the answer without doing the FOIL. It has to do with what's up there. Maybe someone will see it. It has to do with what's happening there. 2 of us, 3 of us maybe picked up on it. Do you see it? Now, see how there's a GCF here? Is there one here? If the original doesn't have a GCF, why would the factor have a GCF? That doesn't make sense. So would you put something there? Let's say this was a choice, right? What if you had something like this? You go, gosh, 2x, and this is like a 4x here. And your factors are, well, plus, I don't know, 2x plus 4, and then x minus 3. Why would this probably not be a factor of some original polynomial or some original quadratic? Because that has a GCF. If your factor has a GCF, what would the original have to have then? Yeah, you got to have a GCF. Now, as we do this out, is that the end of our foldable? Did we get, okay. What we're going to have you do now is this. And again, only doing this because I think you can handle some adult responsibility. Now, as we stated before, I'm going to ask you that you fold it, but please don't fold it down the middle. Did we go over the fold? Did we show the cutting or no? So what you're going to do is you're going to slide up here one at a time. Now, as you can see, these are very sharp. You're going to, now see how it opens? You're going to take some scissors, and you're going to cut along these lines here from the open side, not from the other side, because then it's going to just fall apart. I had to go over that in 2 classes today. Now, you're going to start and see, I only did it once, but let's just say you're at home tonight, you're trying to do some homework, and you go, gosh, I wonder if I could do a greatest common factor on that. But if only I knew where I could find an example of one. All of this is yours. 10 hours of my time to figure out how to copy this stupid thing. And it's all yours. Now, when you slide up, grab some scissors. Are you only going to cut one of these, by the way? No. Someone actually sat down after they did one. You're going to want to do it to all. Don't detach them. second thing, are you going to want to come up here frantically reaching in to grab scissors and then just pull them out in front of it? They're sharp. They hurt other people. And in exchange for not hurting someone else, you can use scissors that actually cut paper. Are we capable of coming up and doing this, or should we independently hand them out, put you in a safe space so you don't hurt yourself or others? Are you capable of cutting this on your own? Yes?
Yeah.
Okay. Let's do this. I'm going to give you 2 minutes. Slide up, grab some scissors. Share with each other. We'll give you 2 minutes, though, to get her done. I know there's not enough. Find people you can share with, split from.
Really?
Help each other out.
This is summer.
That looks like mine though. Oh,
There you go.
have them really,
So far, so good.
I'm the only one.
And then when we get this done.
Loser.
Did you do any factoring in this yesterday or no?
No.
Not even. Okay. Thank you.
This is a perfect square.
Got it. Thank you.
Yeah. That was what, the blue book?
So once that's done, grab a seat, please, and have your note packets out to page 2. When you're done, if you need one, come on over. Any more? Need a packet? So, as we go through and do these, the stuff that we're doing today, we should be able to rip through pretty quick. Did you need a packet? As we do these questions out in the beginning, they're designed to be like not low, well, pretty low level until we get into some of the more complicated ones. But take a look right now, please. Go through and do out the 3 in example 1 right now. Go through, please, and do those 3. I keep your foldable out to the side. Use it to help yourself. To go through, use your foldable to help yourself factor those guys out. See what you need, what you don't. What type it's going to be. Try it out. Hopefully pretty quick. You're just looking to sort of break this down. Tell me, how can I get this expression not by adding and subtracting, but by multiplication? Because if we can list it out as a bunch of products, it's very easy to make the expression equal 0. Take a look at 1a. Hands up, please, when you can tell me how I can break down 1a, or how can I rewrite out 1a? We'll wait till we can get 6 of us. You got 1, 2, 3, 4, so 5. 5. What do you want to say?
9, z minus 2.
There you go. Now, just so you know, and there's some things that we'll kind of maybe address while we're here. If we're talking about an expression in class, we're going to make sure you're using age-appropriate language and not maybe middle school words anymore. What's the name for the position of the x in that fraction? Hands up, please, if you can tell me. When you see something hanging out in this area, you tend to refer to it as this. Yeah. What's that? The x. The numerator is up top. What's the y position called? There you go. So fractions, when we're talking about them, there's a numerator and a denominator. We don't say top and bottom. That's for an outfit. The next thing is when you're trying to indicate to someone parentheses, I don't know how much of this stuff they talked to you about before, but when you're indicating to me, or if I'm telling it to you, if I'm saying it correctly, we would say 9 times the quantity of. If you wanted to know parentheses, the words are the quantity of. Did they do that with you before or no?
No.
Okay. The reason that I tell you, I don't want you to get to a large lecture hall when you're in college and think you're going to rock it on the first day to answer a question, and you go through and say it wrong, and then you're angry at me for the next year, or I guess the next 8, or no, how long in college? 3 months and 24 meetings, because that invariably happens every single time. It's like, well, it's the top of the fractions. Well, it's the numerator. Well, it's the... Make sure we're giving out the right stuff. You don't want to sound foolish. How about for the second one? Hands up, please, when you can tell me. And again, by the way, I don't care if you get it right now. I just hope by the time you get to pre-calc and rich next year, it'll think it's something. What do we want to say for B? Hands up, please, if you can tell me how B can break down. We got 1, 2, 3, 4. What do you want to say?
7 times 21, 8m plus 5.
Now, all we did was undistribute. Perfect. Perfect. How about, please, for C? Please. I was talking about this with some of the kids in Geo that were in this McGee's room yesterday. Does everything in life factor? No. It's okay. It doesn't. It just stays the same. You're good. Can you write this out as a product? Can you write it out as a product? Meaning with multiplication? No. You can't break this up. Can these be rewritten as products? Yeah. Can this one? No. Life goes on. All right, take a look, please, at, let's say we do 2D. Go through, please, and do 2D. I think this is good. Did I do this right? Yes or no? Yeah? Is that what we got? Okay. Recognize too, please, that if you're undistributing from a trinomial, it's going to be something in front of a trinomial still. All we're doing is dividing out the coefficient and pulling out the exponents. Do we have questions on any of these terms? Now, that was a factor by GCF. We're going to show you right now how to do something that is a factor by grouping again. What it's called, did we go over what factor by grouping we could call it? It's a GCF 3 times. It's a GCF 3 times. Take a look at this first example here. Is there a GCF for the expression as a whole? Please understand that this means this is one big giant binomial. Binomials have 2 parts. That's the left side and that's the right side of the binomial. And does the binomial have binomials in it? Yes. Binomials are terms separated by adding and subtracting. Now, is there something, a term that's common on the left and right side of the big binomial? Yes or no? Hands up, please, when you can tell me what GCF you think you can undistribute or take out from the left and the right side. We got 1, 2, 3. Take a look at what's there. What would you like to say? What's left now? Someone different, please. I'm going to undistribute out an x minus 5. What would I be left with if I pulled out, divided out, or undistributed an x minus 5 from both sides? Take a look. This is what was on the left before. What did we pull out? The x minus 5, right? So what am I left with? X plus 6. And then plus, what am I left with over here when I pull that x minus 5 out? Now, I'm kind of done, but not really. I'm done with algebra. Well, I'm done with the complicated math. Now I get to do the easy math. What is there still left to do? what would you get when you put your like terms together?
3x plus 11.
That's it. That's it. By the way, what do I get if I multiply x minus 5 times 3x plus 11? Hands up, please, when you can tell me what on your paper that's the same as. Mm-hmm. Yeah, these guys are the same. They're equal to each other. They're going to give the same answer. Which one is simpler? The first one or the second one? Second one. That's going to be your job a lot, is to go through and see how things simplify down. Take a look, please, at question B. When I look at question B, first thing I look for, look at your factoring chart there. First thing you got to look for is a GCF. Is there a GCF at the top of page 3? Is there? Hands up, you can tell me, what can I undistribute, divide out from both? Got 2, 3 of us. 4, 5. I can take out an m plus n being squared. Who can tell me what's left, please, when I undistribute out that binomial squared from each half of our bigger binomial? We got 1, 2, 3 of us. I hope we can see it. I hope so. We got 4. Perfect. Was that tough? I hope not. Go right now, take a look. When we're doing factoring by grouping, on your Algebra 2 exam, it's most likely going to show up like example 5. Example 5. In example 5, there's 4 terms going across. Are there any like terms out of those 4 we can combine? No. Is there a GCF for the whole thing? Yes or no? Take a look at your chart here, because this is going to help us. Is there a GCF for the whole thing? Yes or no? No. Does this look like a fast factoring question? No. Does it look like a guess and check factoring? No. Does it look like a difference of squares? No. Does it look like a factor by grouping? Yeah. So let's try it out. Look at the first 2 terms. Is there a GCF for the first 2 terms? Hands up if you can see it. We got 1, 2, 3. Not bad. What do you want to say? And what's left when you undistribute the A? So I have A, quantity x minus y. Next 2. What kind of B? Positive or negative? What's left when you take that out? Wait a minute. Remember how in the beginning you said we didn't have a GCF? What'd you just say? Now you do. You made it happen. What's your GCF? There you go. And what are you left with? Now, I just want to show, too, how sometimes you guys get, for lack of a better analogy, trained like dogs. Go over, please, and let's see how many of us can factor down. Oh, wait a minute. Did I go past it? Oh, I think I... oh, maybe I didn't include it in yours. Oh, I'll save it for the next one. Go through right now, please. The only other one that could be a little bit tough, look at example 8 here. In example 8, there's 4 terms. So it's going to be one that we might try by grouping or triple GCF, except we got a problem. Look at the first 2 terms. Is there a GCF? No. Look at the second 2 terms. Is there a GCF? Can I make a GCF happen? Well, you could make an independent guess, or you can read the words directly above it. What could we do to make this be something where we might be able to group? Because as it's written right now, I can't. What's something I might be able to do to make this so it is groupable? There you go. So, literally, I think every arrangement besides this one works. Who can give me any way, can you give us a way you want to arrange it? Okay. Okay, Let's try factoring that by grouping. Is there a GCF for the first two? Is there? Sure, what is it? So I'm taking out a q squared. It leaves me with what? P squared minus 2? What can I take out from the second two? Hands up if you can answer that. Close. Oh, wait, I'm sorry. You said 5. I'll take that 5 out. Here's why. What's left when you take out the 5? I'm going to say negative 2 plus p squared. That's what was throwing me off because the order of it. I didn't want to screw up the order. She's absolutely right. I was just apprehensive about putting that 5. I was going to take it out. Secondly, take out the negative part of it. Are these, by the way, the same? Yeah, so what's your GCF? P squared minus 2, and then your other one is what? Q squared minus 5, or plus 5? Sum or difference of squares there? Nope. So you can let go on that. Now I'm going to tell you this. Here's what I advise for homework for you to do. I think I told you before, you can always check your answers to see if it did factor. There's a website called Wolfram Alpha. Did I show us that before? It's literally write it down on the side of your paper. You just write in Wolfram Alpha. If you go to that website and you type in factor, like it's a Google thing, but it's designed to solve math equations. So if I went in, and the website's called Wolfram Alpha. If I were to go into Wolfram Alpha, hang on, here's this. Let's just I'll show it to you for those who want to see if the internet ever loads. If you type in something like x squared minus 9 and say factor it, it will do it. So here you go. Here's one. You want to see if it factors? Watch this. Factor x squared minus 9, and you hit enter. 2 seconds later, it tries to graph it, but it gives you what the factors will be. Hang on, it'll show up. There you go. Your homework is just on that page 2 through 20 even. Did you get your Math Excel to work yet? I know, I forgot to go over that today. Did you? Okay, don't forget about it. I'm going to extend that for about 4 or 5 more days, though. Okay, so make sure you can log into your Math Excel accounts. And the orientation's waiting if you got it done. Sorry we ran late, guys. Thank you for your work. Great job.
Bye, thank you.
See you later.